Okay, so this is the last part of the review. So this will be 13 through 18. We are going to suppose that 7,000 is invested with 2.2% interest under the following compounding options. Determine the amount in the account at the end of 6 years for each option. Okay, so there are two um, formulas that we used for these, and it all depends on the compounding option. You will use this one every single time unless you see the word continuous. If it is compounded continuously, you will use this one. Otherwise, you will use this. Okay. Now, options means how many times a year it's going to they're going to pay you, or you would pay, in this case, the bank or whoever would pay you. This is your P, which is called your principal. It's the initial amount that you're investing. This is your rate. You must change that to the percent to a decimal. So when you do that, you move your decimal left 2 places. The reason you are doing that is because that is 2.2% out of 100. And that's what it is as a decimal. Okay. Um, and then determine the account at the end of 6 years. That is your time. Time is always, which would be, okay, and this is R, sorry. Okay. Your time is always in years. It is, so that's good. All right, so this one is compounded annually. So that means they're going to pay you one time a year. Quarterly is 4 times. Think about 4 quarters in a dollar. If it was weekly, then there are 52 weeks in a year. Let's see what else. It could be daily, it could be semi-annually. We have a whole, oops, sorry. There is a whole section in our notes on that. If I can find it, here it is. Monthly, I forgot about monthly. That's the most common one. That is 12 times a year. Okay. So this would be all our ends. All right. So, okay. Now that it is annually, quarterly, we're going to use this formula right here. The A is our future amount. So we're just going to fill in what we know. Again, annually, it goes with this. We don't see the word continuously. Our principal is 7,000 times 1 plus our rate. We're going to put 0.022. If you want to put the 0 in front of the decimal, that's fine. Over our n, which is 1, raised to the n times our time, which is 6 years. Now I'm going to plug that in to our calculator just like it is. I know I don't need the ones. I realize that. But not always is it going to be a 1. So that's why I'm going to use it. So it's going to be 1 plus. And again, I just do division, but you don't have to. Again, the 1's not going to do anything, but I'm going to show you how I would just change it for the next problem to a 4. So I don't have to type it all in again. I'm going to hit my fraction because most of you will use that. 0.022 on the top, 1 on the bottom. In my parentheses, my power to 1 times 6, or you can just put 6. And at the end of 6 years, if we did not do anything with our money, just let it ride, we would have $7,976. And we're going to round it to 2 decimal places because money is always 2 decimal places. So that's 34 cents. Okay. Well, compounded quarterly. Our ends are now going to become the ones are going to become 4s. So we have 7,000 times 1 plus 0.022 over 4 now, raised to the 4 times 6. Now I'm just going to bring that back up. You can arrow up, or you can hit, arrow up and highlight it and hit enter, and then go change those 1s to 4s. And we end up with that. If you do not have a calculator where you can scroll up, arrow up, just hit second enter and it brings up the last one. So if I hit it, it brought up that one. If I hit it again, it'll bring up that one. If I hit second enter again, it brings up the one before that. All right, so it gives us, we now have, or would have, $7,984.87 because of that 9. So it becomes 87 cents. Again, money, 2 decimal places. All right, so this last one, compounded continuously. When you see this word right here, you are going to use this formula right here. A equals P e to the RT. So our principal, our initial investment, is 7,000. E to the R, our rate is still 0.022. That's multiplication between it times our time, which is 6 years. Let's see if I can, there, I got it in the middle of the screen. Now, 7,000 E raised to the 0.022 times 6. Just making sure. And it gives us that amount right now. It's not a whole lot more in these, but every little bit counts these days. $7,987.76. Okay. And again, that becomes a 6. So, all right, so let's take a look at our next problem. How long will it take for 2,500 investment to grow to 3,000 at an annual rate of 8.5% compounded semi-annually? Okay, that's going to be twice a year. Assume that no withdrawals are made. All right, so here's what we're going to do. We go back to this formula right here because it doesn't say continuous. 1 plus R over N raised to the NT. Okay, we're not going to use this one because it doesn't say continuously. All right, semi-annually, that means 2 times a year, so my N is 2. This is my initial investment, so that's my P. This is my future amount, so that's A. And then we're going to change this to a decimal, so we have to move it left 2 places, 0.085. Again, if you're not sure on how to do that, that is 8.5 out of 100%. 8.5% out of the 100, and you get that. Okay? All right, so here's what we're going to do. Fill in what we know. Let me see if I can get this. I'm running out of room on my desk. We're going to put our 3,000 right here because that's what it's going to grow to. Our initial amount goes here. Our initial investment is our P. 1 plus our R, which is 0.085 over our N, which is semi-annually, so that's twice a year, raised to N, which is 2 times our years. Oh, we don't know. That's what we're solving for, times T. It's like couldn't find it. All right, so first thing I'm going to do is now our x are our variables in our exponent. All right, so that means we're going to have to use a logarithm to get it to drop down out of that exponent. First thing I'm going to do is get rid of this 2,500. This is 2,500 times this whole thing here. So what I'm going to do is I'm going to divide both sides by that 2,500. What's going to happen is it's going to disappear on that side. And over here, I have 2,500. Now you can leave this like this, or you can reduce that. If you reduce that fraction becomes 6/5. Okay? So it doesn't matter, but you can leave it like that. It's because we're going to use our calculator. Equals 1 plus 0.085 over 2 raised to the 2t. All right, so next thing I'm going to do is I'm going to see what this gives me here. Okay, so I'm going to plug that into my calculator. 1 plus 0.085 divided by 2. Yes, you can use your fraction key there. It's just faster for me to do it without it. And you're going to get this decimal right here. So all we're doing is changing this, figuring that up, okay, or what this is here, okay? And we get 1.0425 raised to the 2t. And over here, again, you can leave it as 3,000 over 2,500, but I just reduced it to 6/5, okay? Hold on, I got to fix my papers. Okay, so now I got to free up that exponent. So what I'm going to do is I'm going to take the log of this here, 1.0425. If I do that to that side, I must do that to this side as well. Log of 1.0425. Okay? When I do that, this log and this cancels that out. And we're left with that 2t. So on this side, I got to go over here, okay? I'm running out of room. Log base 1.0425 of 6/5 is now equal to 2t. Again, we used our properties, log base that of this base, and that cancels each other out. This log cancels that out. It's kind of messy at this point. Okay, last step we do, divide by 2. Now I'm going to show 2 different ways of doing this only because it's easier if you have, and it says we're talking about time, so this doesn't make sense as time. That would be our exact answer, but I have no idea how long that is. So if you have that formula, that button, if you hit math and go down to A, by the way, if you go up, it circles down to the bottom of this list. Okay, so it's just faster to get there, but you can arrow down to A, hit that, and you can type that in 1.0425, move it over there, and you can use a decimal or you can use a fraction. I'm just going to type it in just like I see it. Okay. And now you're going to divide it by 2. And I could have used my fraction key, but I didn't. Okay. So the top gives me that answer. Now I'm going to divide it by 2. And that gives me the answer of 2.1902. Does it say what to round it to? It doesn't, but let's just go 2 decimal places. So it's going to be 2.19 years because it's in time. Okay. Now, let's say you don't have that button. Okay. Now, again, I could have done that by using my fraction key. I can go do this easily. That's on the top. 2 is on the bottom, and I'll still get that. Okay. But let's say you don't have that key, the big fancy little where you put that in. All right, so you're going to have to do the base change formula, which is rather log or natural log. It doesn't matter. I'm just going to use log because that's what that says, of our fraction of 6/5, or you can put 6 divided by 5. It's perfectly fine. It will do the trick. Okay. Oh, I forgot to. Well, let me just go ahead and hit enter. Okay, I forgot to put my fraction in, 1. Now, on the top, I have this, okay, because again, it is the log of this over the log base. Base goes on the bottom, Oops, not there. There we go. Move it to the bottom over our base, which is this 1.0425. Okay. That's going to give us the answer right here. I'm going to hit enter, and then I'm going to divide it by 2, and I still get the same thing. Okay. It's just so much easier if you have that button, but change a base formula. I go back before base change formula or change a base formula, depending on the class. So that's why I'll call it both things. But it's the same thing. Okay, so again, if pay attention to your instructions, it doesn't say what to round it to, so a little over 2 years. Okay, and number 15. Joe places a water bottle inside a cooler. As a cooler cools, its temperature C of T in degrees Celsius. We read the problem so that we know what this is and we know what T stands for, okay? C of T is a temperature and it's measured in degrees Celsius, okay? Is given by the following function where T is the number of minutes. So where T is in minutes. So when we go to read, well, it's minutes since the bottle was placed in the cooler. So when we go to our question, if it gets us our degrees Celsius, our temperature, we put the number here. If it gives us our minutes, we put it here. Joe wants to drink the water when it reaches a temperature of 13 degrees Celsius. So that's where that 13 goes. It goes 13. How many minutes? So we are solving for T. Should we leave it in the cooler? Round your answer to the nearest tenth, so 1 decimal place. And do not round any intermediate computations. You do not use your calculator until the very end. So that's what that means. We're going to put 13 here equals 4 plus 14 e to the negative 0.05 t. All right. We first got to get rid of this 4. What we have to do is isolate this part here. We got to get that by itself. It has a plus 4 with it. So we have to minus 4. This gives us 9 equals 14 e to the negative 0.05 t. All right. Got to get rid of this 4. Again, I'm trying now to isolate just that part. And I probably should have just told you that to begin with. It's no big deal. Okay, so we're going to isolate this. I have to get rid of my 14. So I'm going to divide by 14 because that's multiplying. Okay, so now on this left side, I have 9 over 14. On this right side, I have e to the negative 0.05 t. Now I need to free up that exponent. Well, this has a base of e. What has a base of e? Natural log. So if I take the natural log of that side, I have to take the natural log of this side. That cancels that out and frees up that exponent. So now I have the natural log of 9/14. Okay, I'll just put that in parentheses, it doesn't matter, equals negative 0.05 t. Now we're solving for t by dividing by negative 0.05. See how I haven't used my calculator yet? That's what it's talking about. Don't round any intermediate computation because I don't even know what the computation is. Not until I plug this into my calculator. Now, if they'd asked for the exact answer, it would be this whole thing. But that doesn't make sense because we're trying to find minutes. I don't know how many minutes that is. So, and it says round to the 10th. Okay. So now we're going to use our calculator, and I'll try to do this all using my fraction key because I'm not really good at it. But I just, again, it doesn't matter. It's personal preference. Okay, natural log, I usually do 9 divided by 14, but you probably will use your fraction key. So that's 9/14. I'm going to finish that parenthesis out. On the bottom, I'm going to have negative 0.05. And I end up with 8.8. 8 minutes. And by the way, you can check these answers, okay? You can see if when you plug this in here to see if it gives you 13 minutes. Well, I'm going to use the whole number because again, we rounded. That would give you something close. I'm going to say 4 plus 14 e to the negative 0.05 times this here. And notice I get 13 degrees, and that's what I wanted. Okay, and you could have done the same thing, checking your answer over right there, okay? You could have, I think I still have that in my calculator. Here is the, hold on just a second. Okay, so this answer here was that. I can check that answer by plugging this in and seeing if I get 3,000, 2,500, 1 plus my fraction of 0.085 over 2 raised to the 2 times that big long number. Okay, so I'm going to highlight it. And I should get 3,000. I get 3,000 because that's what I wanted at the end of that time. Okay, I just forgot to check those two answers. Again, you didn't have to. Just thought I'd tell you. All right, suppose the dollar value, V of t, of a certain house that is 10 or t years old is given by the following exponential function. Okay, so we have this function right here. Find the initial value of the house. The initial value is this right here. Okay, so that is our initial value. $344,500. Does this function indicate growth or decay? If this, that's our decimal form of a rate, okay? If that is less than 1, it is a decay. If it's greater than 1, it's a growth because it got bigger. Okay, so right here, it says by what percent does the value of the house change? So what you're going to do is you're going to take, see, because 100% is 1.00 as a decimal. So that's what we're doing. Okay. So we're going to take that number and subtract it from 1. And we're going to get 0.19. That's the decimal as a percent. So you're going to move your decimal or multiply by 100. So the percent was 19%. It changed by 19%. Don't forget to move your decimal to the right 2 places because decimal to percent, multiply by 100 or move your decimal. Okay. 17, a study is done on the population of certain fish species in a lake. Suppose that population size P of t after t years is given by the following exponential function. Okay, find the initial population size. This right here is our initial amount. It's always in the same place. Okay, so our population size, there's 400. All right, does it represent a growth or a decay? That comes from this right here. Just like up here, if it's smaller than 1, okay, then it's a decay, but this is greater than 1 because it's greater than 100%. It's a growth, all right? So again, like, because you can change this to a decimal, I mean, to a percent right now, and that's 136%. Whoops, not 35, okay? How much over the 100% is that? It's 36. Okay, so you can take this and go 1.36, subtract 1 from it, or 1.00, and you get 0.36. So it is a 36% change each year. Or you can do it this way, either way. Change that, and then how much over. Okay, and the very last problem looks like this. We're finally to the end. The number of milligrams D of H of a drug in a patient's bloodstream H hours after the drug is injected into the modeled by or is injected is modeled by the function this. Okay, so we had to read this up here to find out what this is. This is the drug, okay, in milligrams. And T or H, I guess, that is our time in hours. Okay, that's why we read the word problems. So now, whatever they give us in the next sentence or our question, we're rather going to put that number here or we're going to put it here. Just depends on what they give you. Okay, so it's asked for two things. Find the initial amount injected. Well, just like before in the two problems before, that's the initial amount. So the initial amount, say sometimes call this D of 0 or sub-zero, but we'll just write it out. Initial amount injected would be 20 milligrams. Now, just in case you ever see D sub 0 or P sub 0, that still means the initial amount when our time before it started. Okay, so now what we're going to do is it says, okay, so we did that one, and we need to find the amount of the bloodstream after 6 hours. Well, you just put it right there. So you're just going to do 20 e to the negative 0.15 times 6 hours. And you just let your calculator do that work. 20 e to the negative 0.15. Just make sure that you have the right formula, the right equation or function, times our time in hours, which is 6. And so what is, and it says to the nearest hundredth, so it's 8.13 because that's the 100th position, 2 decimal places. And we are trying to find the drug that's left, so that is in milligrams. And that is all.